Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh to our lecturer. This video is about the Industrial Semiconductor Process Project BEEE 3814. My name is Abdurrahim bin Razali. My teammate is Amirul Hafizi bin Syari and Jacqueline Ghani. This video will be presented by Group C, and this video also dedicated to our lecturer IR Technologist Muhammad Syahrin Amri bin Muhammad Noor. So let's proceed to our presentation.
Assalamualaikum warahmatullahi wabarakatuh. Saya Amir Hafizi bin Syahri daripada BEEE Session 2/1, nombor metrik B0818100004. Okey, untuk presentation kali ini saya akan membentangkan mengenai objektif projek, process flow serta conclusion. Okay, for the objective, to remove crack, scratches, air bubble at wafer after mounting process. Also, we want to remove the impurities and foreign particles that may attach to the wafer. After that, to ensure a perfect lamination bubble-free mounting process. As you know, this machine are manual working process. So, we need to design a machine that is the lamination and make sure that it is a bubble-free during the mounting taping. And then, to ease loading and unloading wafer mounting process with the alignment pins and frame. As you know, handling the manual machine need us to align the pin and frame. So this machine will make the handling of the alignment pins and frame become easy. And after that, to provide a low cost operation without reducing the wafer mount quality. And lastly, to design a manual wafer mounting process that are easily to handle. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdurrahim bin Razali. I am from section 2-1 and I am from team C. I will explain about the definition of wafer mount process. So what is wafer mount? Wafer mounting is a phase in the semiconductor production process that occurs during the die preparation of a wafer. The wafer is put on a plastic tape that is attached to a ring during this phase. Wafer mounting takes place just before the wafer is sliced into individual dies. Last, the sticky film that the wafer is mounted on guarantees that the individual dies stay firmly in place during the dicing process, which is the process of cutting the wafer. Next, I will explain about the drawing design of wafer mounting and its function. First, as we can see the mounting tape, the function is hold wafer and wafer ring during dicing process and protect the surface of wafer during back grinding process. Second, circular cutter cut the tape from the roll and cut the tape at the line of wafer ring. Third, cutter cut the excessive of mounting tape. Flip holder, the top cover for mounter design. Top side cover hole for blade to cut mounting tape according to wafer ring shape. Top side mounter cover for top cover cutting shape area. Extension screw to attach the extension to body mounter. Liner cutter for mounting tape cutting area to avoid excessive mounting tape usage, not south. Blade cutting area for mounting tape cutting area to avoid excessive mounting tape usage, south area. Okay, next, for roller strip. As we can see, the roller strip is here. The function is for roller strip to move right and left side. 12-inch wafer indicator area for wafer indicator to place 12-inch wafer. 8-inch wafer indicator area for wafer indicator to place 8-inch wafer. 6-inch wafer indicator area for wafer indicator to place 6-inch wafer. Mounting tape clip holder to hold mounting wafer with clip easier for cutting and avoid it from moving. tape roller to avoid bubble at the backside of wafer, vacuum pumping area to suck wafer and avoid wafer from moving during wafer mounting process, and lastly, the wafer ring frame to place wafer ring for mounting process.
Okay, for the process flow, we have metal plate. The metal plate that we use to place the wafer, it is made of metal so that it will hold the metal strong. And then we have mini vacuum inside the chamber. The size of the mini vacuum must fit and must inside the chamber. And then we have roller bar. Roller bar is made of steel bar, which to make sure that it doesn't break if we pull the mounting tape at strong wind. As you know, the mounting tape is quite adhesive, so pulling it might break if it was plastic or anything else. And then we also add additional feature at the roller bar, which is gear adjuster. These features for that we add this feature to save the usage of the mounting tape. In this gear adjuster working by taking measure of the radius of the wafer. For example, the wafer radius is 5, so we need to adjust it to the 5 to the 5 set, so that the tape that we gonna hold that gonna be pulled from the roller bar is enough. And also we set at gear adjuster to have plus minus 0.2 centimeter of each, so we will not pull additional we will not pull till the mounting tape excess. And then we have rubber fleet holder. Rubber fleet holder is made of plastic, so when we want to open the flip, it doesn't slippery. And then polyethylene terephthalate plastic. It is made polyethylene terephthalate is a clear, strong, and lightweight plastic that is widely used for packaging food. But we use this polyethylene terephthalate plastic so that we can see the process inside the chamber. Okay.
Hi, my name is Yakingani. My metric number is B0 at 1810362. I come from class 3BEE, section 2/1.
So here I'm going to continue my part, which is the flowchart and then the cost estimate. Next, I will talking about material that we use on this process. Firstly, we need to place the wafer on board, and then next place the wafer into the middle frame. The next switch on the vacuum button. Pull the mylar film to each edge of the machine, and then lower the roller by push down the button. Next, we roll the roller to remove the bubbles. Lower the cutting panel to cut the mylar film around. And then next, we cut the excess mylar film by using the cutter. And then we remove the excess mylar film. And then the last one, we need to switch off the vacuum. Then wafer is ready for the dicing saw process. So here is the material that we use in this process. Firstly, we have used the mounting tab, the circular cutter, and then the cutter, flip holder, top side cover hole, top side matter cover, extension screw, linear cutter, flat cutting area, roller strip, and then the next one is 12-inch wafer indicator area, 8-inch wafer indicator area, 6-inch wafer indicator area, and then mounting tab clip holder, and then the next one is step roller. So this is the estimate cost that we use in this project. So the total one is the 254 ringgit Malaysia. So that's all from me.
Okay, as for conclusion, we came out an idea to make a manual wafer mounting machine that can undergo full process smoothly and meets the requirement of our objective. And then we design a manual mounter machine that can solve and reduce some problem that always happen during wafer mounting process.